In this video, we're going to talk about rational functions and the graphs of those rational functions, and primarily discuss the holes and the asymptotes that those functions may have when you graph them. So first we need to talk about what vertical asymptotes and horizontal asymptotes are. So a vertical asymptote is a vertical line that a graph will approach but cannot cross. So it says as a graph maybe goes towards that from the left, it could go towards positive infinity. It could approach it that way. But it could also do the opposite. It could approach it and go towards negative infinity. And again, that could be from both sides. So I could have my graph do that, where I have a graph split on both sides of my asymptote. But I have an asymptote there that the graph is approaching, but it cannot cross. A horizontal asymptote works the same way. We have a horizontal line. The graph, as we go towards infinity or towards negative infinity, it approaches that value. It's kind of like a barrier at the top or the bottom of a graph that your graph cannot cross. It'll just get closer and closer and closer to it as you go towards positive or negative infinity. So that's what asymptotes look like. A lot of rational functions, when you graph them, will have asymptotes. Some of them will have holes in the graph, and we'll talk about that here in just a second. But know what asymptotes look like, and then we will figure out how to find those and graph those whenever we actually graph a rational function. So, given a rational function, the vertical asymptotes happen when a is a 0 of the denominator. So there are lines x equal a where a is a 0 of the denominator. So to find vertical asymptotes, what we are going to do is we're going to set the denominator of a rational function equal to 0, and we will solve, and those values that make the denominator 0 will be vertical asymptotes or possibly holes, and I'll explain the difference as we go through this. And then to find a horizontal asymptote, it's a little bit more complicated. What you do is you look at the rational function as a whole, and you say, what is the degree of the top? So what is the degree of the top part of this, the numerator? What is the degree of the bottom of the denominator? And I'm going to compare those degrees. Okay. So then we have three conditions here. If the degree of the top is less than the degree of the bottom, so that means my highest exponent on top is less than my highest exponent on bottom, then there will be a horizontal asymptote at y equals 0, which is the x-axis. I'll skip to part C here. If the degree of the top is greater than the degree of the bottom, there is no horizontal asymptote for the graph. And the third condition, if the degree of the top and the degree of the bottom are the same, then the horizontal asymptote is y equals the ratio of the leading coefficients. So we're actually going to see that in this problem down here. But you're going to have to know, if I compare the degree of the top and the bottom, how that tells me, what that tells me about my horizontal asymptotes. So our only example here is to find the vertical and horizontal asymptotes, and I again will address what the holes and how you find the holes of a graph as we do this problem. So the first thing I'm going to do is I am always, to find vertical asymptotes, I'm going to factor both the top and the bottom. So to find my vertical asymptotes, I'm going to take this function r of x, and I'm going to factor the top and the bottom. So the top will factor into, I'm going to factor this quickly here, 3x plus 1 times x minus 1. And the bottom will factor into 2x minus 1 and x plus 2. Okay, so we need to be good at factoring to find vertical asymptotes. So we factor both the top and the bottom, and there's going to be a reason why I did both. But it told us that the vertical asymptotes happen when the bottom equals 0. So what I'm going to do now is I'm going to take each of these factors on the bottom and set those equal to 0, and I'll get my vertical asymptotes this way. So if I solve this one, I get x equals 1/2, and here we get x equals -2. That means I have a vertical line at 1/2 and a vertical line at -2 as vertical asymptotes. Now I didn't do anything with the top, but here's why I factored the top. If one of these zeros, one of these factors, was the exact same as one of the factors on top, so if I had an x plus 2 on top to match this x plus 2 on bottom, x equals -2 would actually not be a vertical asymptote. It would instead be a hole in the graph at x equals -2. So the way that would look is the graph would almost seem connected through that. You wouldn't see that vertical boundary line of an asymptote there. You would just see a hole in the graph at that coordinate point when x is -2. Okay, so anytime that you have a 0 on bottom, but the top has that exact same factor, it's not actually a vertical asymptote. It will be a hole in that case, so make sure that you know that. Okay, we didn't have similar factors on top and bottom here, so those are both vertical asymptotes. To find the horizontal asymptote of this graph, all I'm going to do is look at my original function. I don't need to do any kind of factoring, but I'm going to look at the leading terms, and the leading terms show me the degree. So I have 3x squared over 2x squared. I can ignore the rest of it. I'm just looking at that degree and leading term. And because the degree of the numerator is equal to the degree of the denominator, right? They are both the same power. They're power 2. That means that our horizontal asymptote happens at y equals the ratio of the coefficients, which is 3/2. So there would be a horizontal asymptote at the line y equals 3/2 there. Because the degrees are the same, I compare the leading coefficients, which would be 3/2.